So now I will go to the experience and examples what we have done in the last years in Germany. This first example is a municipal waste incineration plant in VII. It's near Aachen. You have here the furnace. Afterwards, this is the old system. You have had a coke, activated coke, blowing in for capturing dioxins, spray dryer, backhouse filter, wet scrubber to stage, and then after all heat exchanger, natural gas burner to go to the temperature for the catalyst, blowing in ammoniac catalyst, and then stack to the environment. This waste incineration plant has 3 lines with each 16 tons waste per hour. The raw gas values in acids are still between 900 and 3000. It means municipal waste with a little bit special waste, not special waste, industrial waste. Sulfur dioxide between 350 and 1000, HF between 30 and 40. The volume stream for each line is 76,000 Joule cubic meter dry per hour. The clean gas values with the wet system, 2-stage wet scrubber, are less than 5 milligrams HCl, less than 5 milligrams sulfur dioxide, less than 1 milligram HF. We found out that at least after changing to a dry system, we get the same results in the dry system in the clean gas. Now, this is the picture for the first line, or for these lines. We changed the wet scrubber, put out the wet scrubber, and changed to dry system. We blow in now sodium bicarbonate in front of the not used spray dryer. Also activated carbon, go over a filter system, backhouse filter. The natural gas burner is still there but not working, but he is still there because 2 or 3 times a year they must heat the catalyst over 250 degrees to blow out or to destroy the ammonium salts which are condensed there. And afterwards, as I showed before, a cooling system where we put out all the heat of this system. So it's really simplified as before. 3 minutes only, oh, that's good. So, okay, the expected energy savings in these 3 lines, and the first one is now validated. We save electrical energy, about 15,000 megawatts per hour per year, natural gas, minus 97%, steam consumption, it means expended use of flue gas heat, plus 84%. The second and last, I think, will be here the MRKW Rosenheim. It's a municipal waste incineration plant in Rosenheim. It's in the middle of the town. And the system before was a semi-wet scrubber. This means blowing in milk of lime, producing milk of lime, blowing in milk of lime in a spray sorption tower, then the backhouse filter and the stack. SNCR with ammonium in the furnace. There we changed also to a total dry system and put out the heat energy in front of the cleaning system. This means Eco 1, Eco 2 is retrofitted, and the spray absorption is still not working, but it's there as dead room. Afterwards, we blow in sodium hydrogen carbonate and activated carbon and go to the stack. We found out that we could increase 10% of burnt waste because the old bottleneck, if you have peaks, you must reduce the amount of waste you burn, are not further given with this FGC system. And we put out at least 2 megawatts per hour flue gas heat, and could also, if it is needed, add another 1 megawatt. For me, surprising it was at least the cost, because the running cost here says that the cost for additives still increased because sodium bicarbonate is much higher, but the cost for residues is much less than before. So here you have still also a plus. The cost for electrical power decreases, spare parts, and also maintenance and repair. And with this system, in comparison with the old system with hydrated lime and spray dryer, we save at least 140,000 euros per year without additional benefit. This comes as plus on top. So I think this can be killed. It's a example from a really good working district heating system, but I think I should stop nearly now. Okay. If you look at least for the picture from the beginning for the BAT, if we have fulfilled with this system and retrofitting wet and semi-wet scrubbers to the system, the BAT criteria, so we can say yes, absorption rate is still really well working. The availability is really high. We guarantee over 95%. It's no problem. Behavior at pollutant peaks is still working well. Investment cost, it's not really expensive. The regulation action is still good. The additive supply cost is still higher. You saw that bicarbonate is much more expensive, but the residue disposal costs are still okay, and the operating costs are also less. And in addition, energy efficiency for the FGD is also a really plus because we put out 2 to 5 megawatts from each line. That's all. Thanks for your attention. I hope the translator worked well.
Bernd, thank you very much for your interesting presentation, and I am sorry. En Joan Salvador, cap de l'àrea de bioenergia i biocombustibles de l'IREC, ens parlarà dels cicles del rendiment en valorització energètica de residus. 15 minuts.
Molt bé, gràcies. Molt telegràficament, agrair haver estat convidat a fer aquesta presentació, felicitar per l'excel·lent organització del Congrés i més enllà felicitar les persones que estan en el dia a dia per la seva meravellosa professionalitat i la seva exquisida cordialitat també. Felicitats. Com que no hi ha temps pel joc previ, ho sento, anem directament a la playmate del Congrés, que és aquesta equació R1 que tenim aquí, que busca que el rendiment de les plantes dedicades, diguem-li, un tractament oxidatiu a elevada temperatura. No podríem dir incineració, sempre podem trobar una frase alternativa que digui exactament el mateix. No parlaré de la fórmula perquè ja ho han fet altres ponents abans que jo, però sí que la utilitzaré i el que vull fer aquí és presentar-vos casos pràctics. Una planta que veurem en l'exemple, això ha estat un càlcul que pretén buscar de quina manera podem millorar una eficiència energètica definida segons aquesta fórmula, a veure quins paràmetres podem jugar per millorar-la, també fent-ho d'una manera molt realística. Els professors tenim tendència amb llapis i paper que ens doni tot i a l'hora de la veritat no dona tot i sempre hi ha algun problema o un altre. Per això hem demanat la col·laboració d'alguns altres professionals que ens fessin tocar de peus a terra en els càlculs que us presentaré ara. Un petit recordatori del cicle de rànquing. Intentaré no donar masses idees, a aquesta hora tots estem cansats, només posar-vos a to. Amb un petit treball podem donar molta pressió amb un líquid incompressible, això és el que fa una bomba. Si aquest líquid a alta pressió li subministrem calor a la temperatura adequada, el convertim en un vapor, encara l'escalfem una mica més perquè la turbina vol un vapor sobreescalfat i finalment un gas o un vapor a elevada pressió quan s'expandeix proporciona una gran quantitat de treball. Aquesta és la gràcia. Finalment anem amb un condensador i torna a començar. Molt bé. Ja s'ha vist també, si volem augmentar l'eficiència de la fórmula, fem cogeneració, intentem aprofitar la calor de condensació que és molt elevada, per tant ahir també se'ns va presentar amb una transparència que quan això es feia era relativament fàcil aconseguir complir amb les exigències de la fórmula d'eficiència energètica.